Friends, welcome back to my channel. When we work in electronic circuits and we use oscilloscope, we need to measure some signals. At that time, when we connect this signal to oscilloscope or to any circuit, it is called coupling. When we connect a wire from here, this connection is called coupling. Now I am connecting this wire, direct coupling. So there is no media between this. It is just only I am connecting this transformer directly to positive terminal of this battery. So it is direct coupling. If I will use some capacitor here instead of this wire, so it will cause capacitor coupling. And if I will use some resistor, if I will connect from this point to this point, it will called resistor coupling, capacitor coupling, direct coupling. The connection between two circuits is called coupling. I received a comment from my viewer, what is DC coupling and what is AC coupling and what is ground coupling in the oscilloscope. When we measure signals, which type of signals we measure with oscilloscope? We have two type of currents. The one that is AC, the second DC, and the third type of signal that is AC plus DC. This is DC source. It is purely DC voltage. This transformer, it is giving directly voltage. This terminal is positive terminal and this terminal is negative terminal. So we have 6.323 voltage. This is DC voltage. And if I will check in AC mode, it will not display anything. Okay, let's check voltage in AC. That is the output of this transformer. So it is 3.7 volt AC. Now if I want to test this voltage in DC mode, it will not measure anything. This was DC signal, so we need to check in DC range. This signal is AC signal, so we will measure in AC range. But this signal, now DC plus AC, it is RMS signal 3.7 volt. This time it is AC plus DC signal, and if I will check in the DC range, it is now varying. It is 6 volt, but it is varying. Its voltage level is not stable. Here it is fixed DC voltage. It is not moving. But when we test this one plus this one, how this signal will come? I have two signals. One is the output of transformer. Here I applied 220 volt. So I am receiving AC voltage here, and I connected this voltage to a battery, positive, negative, positive, negative, and we have now three types of signals: pure DC signal, pure AC signal, DC plus AC. It is offset. Let's see on the oscilloscope and then we will discuss. Now we will use 1x probe, channel 1. Now if we check this signal, this is AC signal, and if we check the coupling, channel 1 coupling, DC coupling. In DC coupling, it is displaying this signal, and if I will connect now, this signal, we can see now this signal is uplifted. When I was checking this signal, it is showing in the center line. But when I will connect this signal here, it is now elevated. it is showing in the upside. The same signal here in the center value. So this signal is in the center, like this, AC signal. Now let's check the DC signal. The DC signal from here, battery positive terminal, it is pure DC signal 6 volt. It is DC 6 volt. And if I will check it, this signal plus this signal, AC signal with DC component, now what will happen? It will give offset the 6 volt and it will show this signal above this line, indicating that there is something offset. There is something in this signal that is lifting up from the zero line. Our pure signal, that is sine signal, it is coming at zero, half cycle in upside, half cycle in low side. But here this signal is now elevated. If you see closely, this is 0 volt. When we tested the AC signal, it was showing here. When we connected DC plus AC at that time, it is showing this signal here. Why? Because we shifted the zero level upside. So in DC coupling mode, in the DC coupling, it will show the both signal, DC component with AC component. Now in this point, if I will switch to AC coupling, in AC coupling it will show just only the sine signal and it will remove the DC component. Why? Because at that time this signal will pass through this capacitor. Normally it is passing through this resistor, but now it is passing through this capacitor. So that is the reason when we use AC coupling at that time, it will block this DC voltage and it will just only allow to pass the AC signal, which are the ripples. At this time, this is DC level. The same when we use a capacitor and we want to test the ripples in the capacitor, this function is very useful to select AC coupling, channel 1 AC coupling, and if we select this coupling to ground, now it will not show anything. Now see inside the circuit. This is our sampler inside the oscilloscope. When we connect it directly through our resistor, or when we connect through resistor and capacitor, the third point, that is ground. This is same signal. Here is input. If we will switch here, at that time it will allow to pass all the signal. Either it is DC, it is AC, it is pulsating DC, it is half cycle, positive half, negative half, if it is sawtooth, whatsoever, it will allow to pass DC plus AC, all signals. And we will see the signal with elevation or in the negative area. When we connect to AC coupling, at that time it will allow to pass just AC signal whatsoever. Which type of signal? It is sine, square, changing voltage. If it is changing voltage, it is sawtooth, these are ramps, whatsoever. The changing signal which have varying amplitude, that signal will pass, other all signal will stop here. And if we will connect to ground, at that time no signal will connected to the sampler. In this condition, it will connect just ground signal to the input of sampler, so sampler will not show anything. The same technique, it will be used in analog oscilloscope, in cathode ray oscilloscope, in DSO, DPO, that is digital phosphor oscilloscope, MTO, mixed domain oscilloscope, MSO, mixed signal oscilloscope, and digital sampling oscilloscopes or waveform recorders. The same configuration it will use, the same function, the coupling will used in the measurement. When we select DC coupling, at that time each type of signal, either it is in positive, either it is in negative, either it have DC level, either it have AC level, either it have distortion, whatsoever, it will pass to the sampler and sampler will show on the display. If it will select AC, at that time all the DC signal, all the DC components will blocked, just ripples, sine, wave shape, any type of wave shape that is here, it will switch to the sampler. Why? Because this capacitor will block all the DC signals. In the ground coupling, it will not show anything. Let's see again. Now connected to ground, nothing displayed on the display. Connect to DC. This time the signal is elevated from the zero line. That means it have offset with positive voltage. We have positive voltage offset. Okay, if I will connect in reverse, that time I am giving the negative signal. So signal is now in the bottom area. That means a negative offset is present there. Either it is negative offset or positive offset. It will transfer in the display. When I will select to AC, it will remove all the offsets and it will allow to pass the pure varying signal, that is alternating signal, which have varying amplitude all the time, that will be passed to the oscilloscope. The DC voltage now is removed. I hope so this video is informative. If it is informative, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.